Good morning, everybody. My name is Alex, and I'll be hosting or facilitating this 3D printing / illustration to 3D printing workshop today. I'm very happy that you all could join me today. I'm sitting looking like a spaceship, but not quite. I'm sitting in the mothership in Cape Town. And I'm a designer and a maker myself. I used to be the fabrication manager at TMG MakerSpace there at Simulofong, who's hosting this Fak'ugesi festival. But currently I'm finding myself here in Cape Town, and I'm working closely with a company called Flat Rock Studios, and we specialize in design and fabrication. From all the smaller kind of things to high-end fabrications. I'll get into that a little bit later. So yeah, today's focus is on 3D printing, obviously, but I want to veer off into a more creative aspect of it, and focus more on illustration to 3D printing. So it's geared for the artist, the designer, the doodler, who hasn't really had an experience with 3D printing yet, and I just want to showcase what is possible and how easy it actually is to, even from a freehand drawing, to get that into a 3D printer and actually create a print. So all the various steps and processes and tricks and shortcuts. We are famous for our shortcuts, and that's always a game changer, especially when you're under pressure. I often find myself, I might have a commission or something that I need to do very, very quickly, and you don't always have the time to design from scratch. And then you have to rely on your bag of tricks and your shortcuts. I'd like to take this opportunity to say hi to Mpo and the rest of the makers there at Simulofong, if that is possible. Hey, how's it, guys? So they are running a live workshop today. Hi, guys. And Mpo he's focusing more on product design today. So he's decided on a product that they are going to design and make. Mpo is one of my interns whilst I was the fabrication manager there. He's a bright young lad. He excels in all sorts of design, fabrication. He's very, very good at robotics. He's actually famous for making robots from trash, aka Mr. Robot. So he's facilitating it there. I see Mia's in the background there as well. She is one of the managers of TMG. Mpoza, say hi to us, and do you want to tell us a little bit about what you're going to do today?
Very good morning to everyone. My name is Shah. Yeah, I think you can see me. Can you see me? I'm saying now, but I know you. Your mic. The mic is on the camera. Yeah. Okay, I'll try to speak louder. Good morning once again to everyone. My name is Mpo Magudu. So I'm a trash robot maker there, and they know me as a trash robot maker. So just to tell you a little bit about Mpo Magudu. So I'm a guy who grew up like having interest in robotics. So like especially when it comes to road construction machines, those are where like actually the machines that I was having more interest on them. Like, I was always following them, especially every places where they were busy like working. I was always there, wanting to see how are they working. Yeah. So that's just a big bio of Mr. Robot. So yeah, I'm the founder of robotics. So yeah, so we focus more on robots for education. So I have some of the robots that I would love to show you. Maybe I can show you one of these robots. So I have a spider kit. So this is a robot for education as well. So one can be able to get that as a kit and can be able to assemble at home. So I also have this robot arm that one can code to do anything. So it's a sort of like the robots that they use for automobile plant. Okay, so yeah, the focus today is going to be a product design. So what we're going to be doing is, okay, so what we're going to be doing is that it's a sort of a key holder. At the same time, you can be able to actually like put your phones like safe instead of just wrapping them and then putting them in your pocket. So it's like a two-in-one product, an object or product. So we're gonna be designing this. So we're gonna I'm gonna be showing like the participants how to like step by step on how to design this this product. So I mean yeah, it's gonna be a quite interesting workshop today. Yeah, I should say yes.
Okay, great stuff. Thank you, Paul. Thank you very much. I wish you guys luck. We'll be checking in a little bit later, like around 1:30, to see what progress you guys have made. And yeah, super curious to see how it goes. You can tell us a bit more then. So, right, yeah, I'm going to continue with my workshop online. You guys can carry on, and yeah, all the best. Enjoy. Okay, cool. Just a quick question. Is there anybody here present that has experience with 3D printing or 3D design, CAD design? You can either answer in the comments or just unmute and let me know if anybody has got some experience yet. Everybody newbies. Okay, a bit of Tinkercad. Cool, yeah. So Tinkercad is a nice place to start. I personally use Autodesk Fusion 360. So that's in the same family, but obviously a bit more advanced, a lot more that you can do there. But Tinkercad is a very, very good place to start. Oh, somebody else is manufacturing. Okay. All right. Samir, what kind of designs? Okay, look, it seems like most people here are still in the beginning phase in any case. So what I want to do first is I'm going to kick off with 2 short videos, just explaining exactly what CAD design is, and maybe a short intro into 3D printing. It's 2 short videos, but it explains super well the processes, and then based on that, I can continue with my workshop. So let me quickly see if I can share my screen here.
CAD, computer-aided design. It's the cornerstone for how we design and build things. But how did it come into being? What are the historical milestones that got us to this point? And where is it going next? To find out, we're going all the way back to the beginning of time. No, we don't need to go back that far. Let's start in 1861, France. French chemist Alphonse-Louis Poitevin discovers a process involving sunlight and a substance found in gum that allows original architectural drawings to be accurately reproduced. The process creates a negative copy, where black lines turn white and blank space turns blue, leaving users with a blue print.
Je l'avais esprit.
Suddenly, designs can be easily replicated and distributed, allowing everyone to work from the same design without fear of errors in reproduction. It's no small coincidence that the second great industrial revolution starts just a few years later. In 1936, British codebreaker Alan Turing invents the Turing machine, which becomes the basis for the modern computer.
You're welcome.
Through the late 40s and early 50s, mainframe computing is introduced and goes commercial. And by 1955, transistors start replacing vacuum tubes, exponentially accelerating processing speed. Then, in 1961, renowned computer scientist Dr. Patrick J. Hanratty joins General Motors Research Laboratories and helps develop DAC, Design Automated by Computer. But it's Douglas T. Ross, computer scientist pioneer and father of computerized machining, that coins the term CAD.
Let's call it CAD. Okay, hooray!
Acronyms aside, to this day, it is Patrick Hanratty who's known as the father of CAD. In 1971, while Intel is busy introducing the microprocessor to the world, Hanratty introduces the CAD software known as Automated Drafting and Machinery, or ADAM for short. An estimated 90% of today's commercial drafting software can trace their roots back to ADAM. In 1977, CATIA, the first 3D CAD system, launches, running only on exclusive proprietary hardware. But by 1981, with the release of the IBM PC, desktop computing becomes affordable to the masses for the first time, and we see the beginning of the boom that would soon follow. On its heels, in 1982, John Walker founds Autodesk, and later that year introduces AutoCAD, the first significant CAD program for the PC, changing the world of design forever. Over the next decade, huge strides are made in CAD-based software. 3D modeling is introduced, opening the door to innovative design solutions, like BIM and digital prototyping. Settle down, class. Over the next few years, Autodesk introduces a steady stream of game-changing features, further embedding AutoCAD in the design industry as an indispensable tool of the trade. Class dismissed. In fact, in 2007, Autodesk ships their 8 millionth copy of AutoCAD. From 2010 on, advances continue to be made, including a web-based mobile version of AutoCAD that frees designers to work from anywhere, and Autodesk Recap, technology that allows users to create designs using real-world data captured from photos and laser scans. This is the evolution of CAD, from blueprint to desktop to cloud. Today, we see the Internet of Things continue to provide data to build smarter cities and better products. And eventually, generative design tools will use the infinite computing power of the cloud to change the very way we work, as our computers will begin to have opinions of their own and even begin to create designs for us. We'll have reached the point where the term computer-aided design truly means what it says. The tools of design have come a long way, but the story of CAD is really just beginning.
All right, so let's jump into our first CAD software. We can start with the easy one, and this is also Autodesk. So you've noticed the name Autodesk come up there. So one of the leaders in computer-aided design. And Mesh Mixer is an open source program that helps you to modify meshes. Now, a mesh is basically a structure that is made out of polygons, or a mesh, or imagine like a fish net. A bit later, I'll show you an example. And that is actually how we create our 3D models. So the most important thing to understand right in the beginning is also to understand the difference between what is raster and what is vector. Now, a raster image is your normal kind of like a photograph or images that you'd work with in Photoshop, and it is made out of pixels and dots per inch. What we are more interested in, or that we are geared towards, is the vector image. Now, this is more of a mathematical image or a pathway. Now, I'm going to show you how to start with whether it's a hand sketch or a raster image and how to convert it quickly into a vector, and then using that vector, and from there creating our 3D models. But first, yeah, let's have some fun with Mesh Mixer. So what's nice about this is you can import all sorts of files here. There are millions of 3D files freely available on the internet. I'm going to show you now. And it's got its own little bunny toy here that we can work with. So I can immediately just go and grab the bunny. And there we have a 3D model already. And if I have a look here, so there are my polygons. So you can see it is made out of thousands of little triangles. So that is called the T-spline or polygons, and that is the mesh. That is what we refer to as the mesh, and that is how you create your 3D model. Now, the more polygons there are, the more detailed and intricate your mesh is. And the less polygons there are, the more basic. So even like there is actually a style that's called low poly. It looks very edgy. And the way the guys do that very quickly is they just, they drop down all the polygon counts, and then you get a low poly model. Okay, so I just want to exit that. In Mesh Mixer, I can modify my 3D models. Either I can resize them, I can alter them. There's actually a bit of sculpting that I can do. So I can actually, if I show you, if I take a brush and let's do a pull and strength. So I can actually go on my bunny and I can sculpt on this model. Okay, it's not the best sculpting software out there, but there's quite a number of things that one can do. I normally use Mesh Mixer to correct 3D prints if there's something wrong with it. Okay, I want to show you an interesting feature that one can do. So this is one of my shortcuts. So let's say I need a model. Maybe I need to make a bespoke mug for somebody, and I need to put, I can replace the handle with an actual ear, for instance. It's very easy to do in Mesh Mixer, and I'm going to show you how that's possible. So now all I do is I go onto the internet. Let me clear my chats here. And I will go to Thingiverse. And Thingiverse is an online universe for 3D models. We can see that Halloween is coming closer. There's a lot of jack-o'-lanterns. There's a nice detailed, what is that? Is that a raven skull with a nice pattern on it? Some other nice toy-like games, some practical stuff. 3D printers are normally built out of these balls of years, like little attachments and gadgets that you can put on there. Here's an interesting looking hand-like hook that you can use, and very practical stuff. This guy has now gone the extra mile to know. He obviously likes a lot of caps. Okay, so anyway, and there you see something similar to a low poly kind of design. What shall we, okay, let's send Bunny to heaven. Let's give him wings. So angel wings. Some angels there. Oh, yeah, there's a perfect. There we go. Cool. So all I need to do is click on that. And I'm already able to download these files for free. Now, at the moment, Thingiverse and Thanks as free platforms for 3D models. However, it does have a function here. You can tip the designer. Now, you'll be amazed like how many talented people are out here in Thingiverse and they share all this stuff for free. It's truly amazing. There's some true artists that share all their files for free. And it shows you how many times this has been downloaded. This one, not so many times. It's one file, 8. Other people will take it and remix it, like what I'm going to do now, and then they'll post that on there as well. So all I need to do is download. For more engineering type designs, there's a website called GrabCAD. Now, GrabCAD, you can find it's not so commercial as Thingiverse. There you can actually find machine parts, motor vehicle parts, some high-tech elements. Still downloading. Okay, it's done. Let's open that up. All right. So I'm going to go back to Mesh Mixer and I'll go import. And now it's asking me, do I want to replace or append? I want to append. And there's my wings. Open that up and bringing that in as well. So now you can see I've got 2 objects in here. At the moment, we're on the wings. So I'm just going to transform it quickly. Let's get the placing right here. I think that looks about right. I need to tilt it a bit more. I need to tilt it like that. Okay, yeah, I think that will do. A little bit up. Okay, yeah, that's good enough for council work. All right, so immediately I just did a combination and I created a very interesting new model. Now what I can do is I just select both of them and I combine. And now it's one STL model. I can export it and it's ready to be 3D printed. Quick and easy. That's a very, very a good shortcut to use, especially if you have to do something very, very quickly. All right, let's move on to the next. I'm going to jump into Photoshop next, just to use as an example what one can do when you grab an image from the internet. I'm first going to grab a raster file of the internet, and then I want to convert the raster into a vector. So let's have a look. Okay, since Halloween is coming up, let's look for old Jack O'Lantern. And we'll go to images. And I need an illustration drawing. Okay, yeah, here's a sick looking one. Now already we can see that this has got a watermark. Now this is the problem with a lot of images online these days, as they have watermarks. So I can show you a quick tip how to actually get rid of that as well. This is the home. Let's go save image as. Bring that into Photoshop. All right, Photoshop, also CAD software. It's computer aided design. Now, a very easy thing to do, and I find myself doing this often, especially when designing, when I find the perfect picture online and unfortunately there's a watermark, it's actually a very easy way to do it. Ooh, now you see, okay, so even this image has been locked. I actually can't unlock it. So what I need to do is I actually need to do a trace. So if I go Command-Shift-4 and I actually trace the image. Okay, now I'll have to go back to my desktop and grab that. So yeah, if you know your way around the softwares, then anything is possible, really. Go to adjustments, and all I'm going to do is work with the levels. I put a level filter over here, and that will allow me to work with the contrasts, the shadows, the highlights, and the intermediate. So all I need to do now is, as you can see, there's some detail in the shadows. So I'm going to bump up the shadows. That disappears. And I bump up the highlights, and that disappears. And boom, I've got a nice, crisp, clear image. Right, now I need to go and save this as a PNG or a JPEG. So file, save as. We can just do a JPEG, that will be fine. And save it to the desktop. All right, next step. Now, before we carry on, so this is a pixelated image. It's a raster image. I got it from the internet, and I just took a screenshot of it. So if we zoom in, look there. There you can see the pixels starting to distort. The closer I go in, you can see this is a pixelated image. So this will print out fine only to a certain size, only really to its original size or maybe 50% larger. After that, the image is going to get blurry. Okay. And also I cannot use this in my 3D modeling software. I can't use the raster image. So from here now, I need to create a vector, and I'm going to show you a super quick shortcut. I go back to my desktop. I go to, which one was it? Is it this one? Yeah. There we go. Okay, now I like the Adobe products. I do have a subscription with Adobe. There are free open source options available. For a vector program, one can use Inkscape. It's got most of all of the same features, and it's for free. I like to stick to my guns. I'm used to Illustrator, so I prefer working in Illustrator. All right, so when you look at the top tab over here, you see that there's various platforms that I can work in. I can work in essentials, layout, painting, printing and proofing, tracing, typography, web, etc. I'm normally in the essentials tab. That's normally where I function. So first I just need to select. Okay, I select my image and now I'm going to go to the tracing tab. Excuse me. Let's grab a glass of water. Okay. You drag it over so you can see what's happening. In tracing, there's a default. Now I've got various options here. I've got a black and white mode, and that's perfect for me at the moment. There's color, there's grayscale, and there's a threshold. So you do have some room for maneuvering here, but I think the default is going to be perfect here. And I just hit trace. It does its magic. I think it's done already. And let's zoom in now. Look at that. Crisp. Okay. So with this vector image, I can literally go to a high-end printer and I can print a banner that can cover a whole building. This vector, I can blow it up as big as I want. Okay. And the reason for that is because the image is a mathematical equation. You can scale it up, you can scale it down. Okay. And this is what we are after. But we're not quite done yet. So what I need to do from here is I need to get an outline that I can then send to my 3D slicing software. Okay. Now, how do I do that? So the first thing I need to do is I need to expand the object. Go expand. And I only need to expand the object. I don't want to fill it with anything. Then I need to go to the Pathfinder. I'm going back to the Essentials tab. And under Essentials, in the Pathfinder, because remember now this image is all pathways, I just go outline. And there it is, nicely outlined. Okay. I think I need to make my outline a little bit thicker. So let's just see if I can change that. Make the color black. And make it 1 point. Yeah, that should do. The only thing that's still a problem here is that everything is grouped together. So I just need to go and ungroup it. Ungroup. Okay, and I don't need the frame. I just need Jack. Okay, Jack, let's take you to the next step. So I'm going to go File, Export, Export As. Now I can export it as a DXF, which is also great for CAD softwares. But my experience has taught me that SVGs actually work better, works better in my Fusion. And let's call him Jacko. And he's going to desktop. Okay, cool. Now let's get into the exciting softwares. Now we're going to open Fusion 360. And this is our modeling software. Autodesk Fusion 360. Their flagship is Inventor. Now, I mean, you can literally design a plane engine with this software. I think people have done it already. You can see all my previous stuff that I've been busy with. And the good news about Fusion is if you're a hobbyist, you can use it for free. So for any of those who are interested in downloading it, you can always ask me. Sometimes it's a bit tricky, but if you find the right link, you download it, you start a 30-day trial. As soon as the trial ends, then you can just say, I'm a hobbyist, I want to use it for free, and you can use it for free. If you have to purchase a license, it works out quite pricey. I think it's $60 a month, and yeah, it can get pricey. All right. I just want to show you. So I'll put the origin and the grid on here. Okay, so this is basically my 3D landscape over here. And I've got my various planes. So that's X, Y, and Z. And now how it works, it always, with design, it always starts with a drawing. Well, I lied. I guess it starts with an idea first. But then the very first design element is a drawing, okay? And even 3D modeling software, you always start with a 2D drawing, and from there you extrude. You blow it up into a 3D model. So I'm going to insert SVG from my computer. Desktop, Jacko, there he is, open. And now it's asking me like which plane, on which plane. So I can put it on the front plane or the bottom plane. Let's put him on the bottom. Let's center him. Okay, running out of space here. I need to make my screen a bit smaller here. Okay, that's better. That's okay. And finish sketch. So there's my sketch. Now I'm ready to go into 3D. I can kill the origin. I can also disable the sketches if I need to. So all I need to do, so what can we do? Let's turn him into a keyring holder as well, and we're just gonna inflate him into 3D. So I'll window select him and create, extrude. Extrude is pushing and pulling. And we're going up. Let's go up by 20 mils and hit enter. Okay, but so now we just have a flat shape and there's not much happening there, so it doesn't really look like Jack anymore. But that's not a problem. Let's go back to the sketch. I'm going to disable the first body. All right, so what do we need? We need all of these details. So if we go and select, yeah, okay, the outlines, his eyes and his grimace, I'm going to enable that body again. And I'm going to extrude again, but now extrude from the top down. So I'm just going to select from object, select the object, and I'm going to go 5 mils down, -5. See what that does. Wham. Okay. It's just processing, it's taking a bit of time. That's the other thing. When you are using, so Fusion 360 is a cloud-based program now. You still download it, but it works better. It communicates with the cloud. But you need a fairly strong CPU and you need at least 8 gigs of RAM. It's very, very powerful software. If you have a weak computer, it's going to drain your computer and it's going to freeze. Let's disable the sketches. Okay, cool. So now we've got some cool relief in there and it's looking cool. But we can do a final little touch. Let's select this guy here. Okay. Again, I'm going to start from the object. And this time, let's go 10 mils up. maybe too much, make it 5. And it will join to that. And there we've got our first 3D model. Actually switch off this grid. And for a final touch, let's put in a peering hole. So I select this face. I'm going to put a sketch on there. I'll put a circle, put it about there. I'm sure 6 moles will suffice. Finish sketch. So now I just select. So these softwares are very, very intuitive. Very, very intuitive. It's amazing. And they're getting better as AI develops. These programs are super awesome. I'm going to extrude again. And I'll just cut straight through there. And there I've got a little hole. And yeah, there I've got a product. I've got a product that I can actually print and give to my friends or even sell, you know. And let's give it another final touch on the bodies here. So the other nice thing is this Fusion can render amazingly. And this comes in very, very handy, especially in my line of work, as the clients always want to see what the end result is going to look like. So not only have I designed it now, but I can render it realistically so that it's going to look exactly like the end product. And in the design and manufacturing world, it is vital. It's going to give you the lead over your opponents. Should there be any discrepancies, you can always go back and say, well, you know, it's looking exactly like the original design. What's the problem? And yeah, for me, that's a very, very important and super cool feature. So if I just go and change appearance, let's see, let's just use paint. So there's all sorts of elements: fabric, glass, leather and cloth, liquid. I'll just go for a paint job, and let's actually use a powder coat rough. I don't think that, yeah, that one will, this yellow will do. Okay. Now we've got, so we're closer to our color as well. Yeah, one sick looking jack-o'-lantern. Now from here, I can go into rendering. Let's actually render this, why not? I hope so the rendering actually, yeah, so it'll put it into a rendering setup. And if I go to my setup, like scene settings. So for instance, the source of light, which direction is the source of light coming from? Yeah, maybe something like that. Solid color, that's all good. Camera perspective, yeah, I'm happy with all of that. I'm not going to faff too much with that. Could make it a bit darker. The color, let's make it a little bit gloomier. Yeah, that's better. And I just go and heat render. So you can see render settings. Okay. And heat render. Oh, I need to save my design. Okay, the cloud renderer you need here, I actually need some tokens. So I'm going to have to buy tokens to get, this is the best renderer, but there's absolutely nothing wrong with the local renderer. I'll go all the way to final. and I prefer to have a TIFF on compressor. This is high quality. I can make it a little bit bigger though. Yeah, that's better. And I hit render. Local rendering is started. Now this can be timeless. This can take anything from like 2 minutes to half an hour, maybe even more. I can hear my computer's fan coming on. So now it's breaking a sweat. It's working. Okay, whilst that's happening, let's jump to the next adventure. Let me take this opportunity to take some questions, if there are any. Is there anything that comes to mind? Okay, everybody seems to be happy. All right, so there I showed you grabbing an image from the internet, going through a couple of steps.
Sorry, Alex.
Yes.
Is a question from TK.
Okay.
Yeah, Alex, my question is just based on, you had mentioned that one should have at least about 8 gig RAM.
Yeah.
In terms of just the type of graphics card that maybe one should use, what would you suggest or advise in terms of the graphics card?
The best. Just get the best. i5, any i5 and i7 well, i7 will obviously cope, but i5 is also good. To be quite honest, your newer machines, it's just the motherboards are just so much better and faster. So like even compared to an i7 that's 2 years old, you know, so I would say the minimum is an i5 with 8 gig with a decent graphics card. For CAD, I mean, I don't even have the right machine. I should be having a really powerful machine. Problem with them is they're pricey, you know. To be quite honest, if when you start getting into CAD, you need a machine that's like 20K and up. It's yeah, you need a bit of a beast. So laptop wise, my best advice is get a gaming laptop. If you can get a gaming laptop, then everything in there is gonna be cool. But it's not a must. It's not a must. I mean, we've made do with it. The only problem is, you know, especially on a big job, you get stuck and it freezes. And that is very annoying.
All right, cool. Thanks.
Okay, cool. Okay, so what else can I show you? I can show you, since we're busy with illustration, I can show you, for instance, how I illustrate in Illustrator. Give you a quick tip there. So we'll go to the actual drawing phase now. And I just want to show you a cool function. It is a different way of drawing. So it's basically drawing with shapes. Just by using your various shapes. Now, everything in nature can actually be boiled down to the cube, the cylinder, and the sphere. And I'll illustrate that shortly. But just by using those three elements, you can draw anything and in detail. My art lecturer, she showed me. It's like, and it's actually Cezanne. Cezanne was the one who started finding the cube, the cylinder, and the sphere in nature. So a very, very simple exercise in Illustrator, for instance. Let me draw Okay, one circle, and then I'll draw another one. Oops. Okay, 3 circles, and what next? Let's put a polygon. Okay, let's turn it around. So just put a triangle there, and change the size. Guys, excuse me 1 second. I just need to hand some keys to somebody. I'll be back in a flash.
How are you? I'm good. Are you going to it today?
I'm working online, so I'll go to online.
So what time is it? All right.
Bye-bye.
Okay, sorry about that. So yeah, let's draw. Let's start with drawing an ice cream, for instance. Okay, there's our ice cream. Now, the nice thing with Illustrator, with the Pathfinder, is you can go and combine. So if I go to Essentials, Pathfinder, and I combine it, then it combines that shape automatically. And yeah, it's quite a magic tool in this regard. It's a different way of drawing. Now let's add a cube to the mix. Something like that. Okay. Combine. Let's do another. Circle. That's fine. You can do an arc. Put a arc there. Put another circle there. Okay. Oops. And use the line tool and use the pen tool. All right, so what started out as an ice cream is now some kind of a bird. Okay, so just showing you how one can actually draw with shapes. The nice thing about this is all pathways. So I can go and save this as an SVG and take that back. I can take that back to Fusion extrude it and create a 3D model. Okay, so just like an interesting illustration technique to show to you. And this is very handy with stylized. As you know, you get illustrators who are very, very stylized in their designs, and this is how they do it. Let's go back to Fusion and see if that render is complete. Okay, I actually get it now. Sometimes I have this problem, it's rendered, but I don't know why. Okay, anyways, I'm going to go back to design. And if I go to bodies, so now I can save this as a mesh. So this is my mesh that I'm going to send to my 3D printer. However, there's one final step that is still waiting for me before I get to the 3D printer. And I would like to take this moment to share another short video with you guys, just explaining the 3D printing process. So this is a short little video, and then I'm going to take you into the slicing software. We're going to slice this, and then that will be ready for 3D print. As a matter of fact, I'm actually going to see, maybe I can email it to Impor, and then he can print it for us. That would be cool. I'll see if I can do that. The file format 3MF. I'm not going to save this to BMF. I can. This is a new file format. What's nice about 3MF is it keeps color memory as well. So modern printers, the printer will actually know what color to do it in. But I'm just going to go with the original STL format. STL it's short for Standard Triangle Language. This polygon, all the triangles, Standard Triangle Language. And I go OK. And yeah, let's do it. So Jacko STL. And save. Let's have a look. My next set of software, next of my tools is Cura. Now Cura is a slicer, and the slicer will slice the 3D model into layers. So as you already know, the 3D printer starts from the bottom and builds layer for layer. So the software needs to understand that. And I open that file. There we go. Okay. I'll just turn it around. Okay, so he's quite big for a key holder. That the bed size here is 400 by 400, so it's 40 centimeters by 40 centimeters. So this is a bad boy. This is a big boy. So I'm gonna scale him down. Let's go down 50%. That's better. All right. Okay. This is for this. So Import doesn't have this printer at work. The quality, I'm going to do it as a quick print. I'm going to change the quality from dynamic to standard quality. So this is now the, it's exactly like your inkjet printers, you know, whether it's fine quality or draft, basically. Let's go standard, 0.2 millimeters. I'll keep all my settings. Material, yeah. Speed, yeah. I don't need supports. No supports. Bold plate adhesion, none, I don't need. Okay. There are a lot of detail in here. For anybody who starts slicing, this becomes the holy grail for anybody who is into 3D printing. Once you understand all of these settings, but that is a whole workshop on its own. But yes, if you have all your settings in order and your machine is calibrated, then you will get super cool prints. If it's not, you're going to be super frustrated. And that is part of the 3D printing game. It can be a very frustrating game. You need patience and you need a lot of diligence. So just in the beginning, especially, just to, once you understand what to look out for and the rest. Okay, let's slice this guy. One hour, 39 minutes. Okay, let's see if Mpho can actually print this for us. I'm gonna go save to disk. Okay, so that is, it's converted it into a G code. So the G code is for the Arduino microprocessor to understand, and that will instruct the 3D printer exactly how to print this model for us. And give this guy a call. Okay, let me see if I can get a hold of Brandon and ask them to print this for us. If we go back to Cura and we have a look at the preview. So remember, this is, it's sliced it now, and here you can actually see so we're going back and if we start from the bottom, so this we start with a bottom layer and then coming up. So that's got a 10% infill, and it's a cubic pattern on the inside. That's the thing with 3D printing. You're never gonna, you can print it as a solid, but it's going to take so much longer. So in this case, it would take 10 times longer to print this whole thing as a solid. So what it does now is it breaks it down into a 10% infill, into a cubic pattern, and that builds up. You've got a 1.2 mil wall there, and layer for layer, that's how the print is going to come into physicality. Let me try to find someone else there. Yeah. All right, so there is yet another part of the puzzle, how to get it into 3D printing. Okay, doesn't seem like the guys are answering there, so I'll try again a little bit later. Okay. Okay, so we did a bit of illustration there in Illustrator. The The next one I can show you guys is actually how to do a freehand sketch, and even how to convert a freehand sketch from Photoshop. I use Photoshop as a platform, but you can literally draw on a white piece of paper, scan it in, and then similar processes to get from the 2D drawing to a 3D model. I'll go to Photoshop. Let's go and get a design. I found this design online. So there's quite a detailed tattoo of a swallow. Select it all. New artboard. Let's do it on A4. Let's blow it up. If I can, oh, here they come. Hey, Kazi, you do me a favor. I just sent the STL to Paul's email. I did like a small little jack-o'-lantern keyring as the presentation, and then I just got the idea. If you maybe you guys can print it for us. Do you think there will be a bit of time on the? Okay, cool. You'll see it's just a small jack-o'-lantern. Yeah. Yeah. Excellent. Have you got like a yellowish orange filament? Is it? Yeah. Use that because it's a jack-o'-lantern, so that'll look dope. Okay. Oh wait, thank you. Cool, sorted. All right. So we can use. So yeah, I'm going to use that to trade. Oh. Hey Mia. Alright. Ek is hier nog in die middel van die workshop. Ja, ek het vir Brandon gebel. Ek het vir hom 'n paar STL gestuur om vir ons te print. So ek kon hom net nie in die hande kry nie. Toe dog ek wel net vir jou. Brandon, ag, pos die e-mail en ek het net met Brandon gepraat. So he's on it. Cool, thank you. Thanks. Sorry guys. So I'm going to use this image to trace. My freehand is a bit rusty at the moment, to be quite honest. So what I can do is I put it on its own layer and I bump down the opacity to about 50. I create a new layer and oops, sorry about that. Photoshop. Okay, it's fine. And I'll select my brush tool. Here we go. For this purpose, I do have a tablet here, so I prefer to use my pen and tablet for this. It's a bit difficult to draw with one's mouse. It's possible, but yeah, you just don't get that fluidity. So yeah, I'm going to focus on the outlines. And the nice thing with the tablet is if you're not happy with your stroke, you can always go and delete it. So you can, until you're happy with the quality of the stroke. So I'm just going to focus on the outlines. Focus on the outlines first, and I also need to make sure that they actually connect, especially the outlines. The inside won't be so important, but I must just make sure that my outline is going to be a continuous line. So the idea is, yeah, it's just to give you guys like an introspection on various ways, like all kinds of different ways, from illustration to fabrication. We'll go a little bit more high end just now, where I'll actually go and I will design in Fusion 360. But it's important for me to showcase these methods, especially for those who are not familiar with the CAD softwares yet. And this just shows you it is actually possible with a limited understanding, or there's more than one ways to skin a cat, basically. Yeah, must just remember to connect. Yeah. Make sure that they connected. Should actually do this more often. It's quite a meditative process, drawing. I don't do it as much as I would like to. So yes, like I explained, doesn't have to be in Photoshop. You can do it on a piece of paper, just scan it. And from there, same process. So if you don't have Illustrator and you want to do it for free, you can download Inkscape. And in Inkscape, you can trace it and then it's vector ready. So I've explained that whole process. And from there, it can go into a 3D modeling software and it can be printed or manufactured. Okay, so we've got the outline. The outline is done. So our basic shape is then, yeah, that's sorted. And then we can go and put in a little bit of detail. just to give our design a little bit more resolution. Now, these elements don't necessarily have to touch. As a matter of fact, I prefer that they don't. The only reason for this is I need to do something quick. They can be touching, but then it's going to take me a little bit more of editing to do. And that would be then in this when I extrude in Fusion 360. So all I'm going to use these elements is just a little bit of a relief. So just very quickly, I mean, if I wanted to, I could spend a bit more time on detail. But for the sake of the exercise, let's see how quickly we can do it. A little bit of a tendon there. Okay, a little bit of details there on here. And just, just touching on those details, just a bit of, to give us a better understanding of the shape of this creature. Okay. That is good enough for council work. And there we go. So there we've got a quick freehand draw of a swallow. And I'm going to save this guy. File, save a copy, save as JPEG. I can save it in there and swallow sketch. All right, now from here back to Illustrator. Like I said, you can use Inkscape as an open source. All right, and same process. I'm repeating this just so it also sinks in and the understanding of the process is clear. So select, I'll go back to my tracing and just a black and white trace. Quick sticks. Okay, so it is noticing a lot of angles and edges, so it says it might take a bit long. It's not going to be too bad, but this is more of a complex drawing. There are lots of nooks and crannies and little corners, and you're going to see now what I mean with the 3D software. Let's zoom in and see. Okay, yeah. All vector lines, all nice and crisp. Ooh, got a problem. That one is not touching over there. It's gonna be a problem. I have to maybe just do a fix there. Should be right. Let's double check. Yeah, I think that will be okay. Okay, and you guys can remember, so now I go File, Export, and export as SVG. Send it to my desktop. All right. Okay, let's see what's happening here in Fusion in the meantime. The render, can I open it now? Yay, there it is. Cool. I'm going to download it. So it's going to download it as high quality TIFF. Yeah, and look at that. So the rendering makes a big difference. That looks fairly realistic. It looks fairly realistic. It looks like a plastic jack-o'-lantern keyring. Okay. So yeah, the rendering is a huge added bonus. And as I said, use it very often. Now, to just talk about fabrication and what we get up to here at Flat Rock Studios, we do a lot of work for private and commercial clients. Any sorts of fabrication. We use laser cutting and CNC quite often. We've got a foundry in the workshop. One of the partners there does casting in aluminium and in bronze. We basically do anything there. There was an engineer that was building stainless steel grids. And we've been commissioned to do a lot of work for artists, and there's a huge installation that will take place soon where we have to build these huge sculptures. A lot of them too complex to send off to artists, and there's also not budget to send it to artists to be hand sculpted. So one of the things that we will be doing is we'll do the designs ourselves, and that will be sent to our friends who've got large format 3D printers. They will be printed, but then there's a lot of spit and polish that still needs to happen from there. It needs to be refined. It needs to be either a mold being drawn from it, then being casted, and at the end, obviously painted. So yes, we do utilize 3D design and 3D printing quite heavily, and it comes into play, especially when it comes to sculpting. Okay, we're going to open a new file, and we're going to insert the SVG. Desktop, swallow SVG, open. Select the plane, drag it to the center. Okay. And finish sketch. All right. I don't really need the frame. Okay, I think I'm going to close some of the files and softwares. My machine is taking strain, actually. Okay. Okay, let me just close all of that. Let me at least just close Illustrator. Still have to show, I can close Mesh Mixer. What do you want? Okay, same process as before. I can go and window select it. And you're going to see now it has to register a lot of points. So it's going to be a little bit taxing on it. Let's give it a bit of time. Okay, let that carry on. What's going on here? I can close this one as well. All right, freeing up some space. Sure, it's taking long. Okay, yeah, so lots and lots of connection points. Okay, so it's looking good. I can see the whole shape. It means that all the lines connected on the outline. That's important. Otherwise, it would have been a bit messy. And I want to extrude. And let's go up 20 mils. Okay, so there is actually an error somewhere where it doesn't want to allow me. And that might be okay. Okay, so somewhere there is actually not a connection. So I'm going to try something else. Okay. Okay, I think the best, what I'm going to do is I'm just going to restart Fusion. I just want to, cause it's, yeah, it is actually, it's taking too much of my CPU. All right. Okay, cool. I'm going to come back to that one. In the meantime, so I showed you Cura as the slicing software. And there is another interesting slicer that I found recently. So recently, and it's actually referring back to one of the sculptures that we had to present for a client, and it needed a coral texture. The whole sculpture had to have like a coral-like texture. So there are obviously many ways that you can tackle this problem. You can get a sculptor in and he can come and carve out everything. And we thought, no, let's see if there's not a solution online where one could actually use 3D printing to create a texture on a 3D model. And I found one, and it's in the form of Idea Maker. So I'm going to launch Mesh Mixer again. And this time I'm going to import a sphere. I just want a sphere, and I'm going to export it as a STL. Just call it sphere. I can actually go ahead and close this again now. And all I need to do, so this is exactly the same as Cura. So now I've got the 3D model, which is the sphere. I'm adding it. Okay, there's my sphere. It's a little bit small. Could maybe make it bigger. Maybe make it 500% uniform scaling. That's better. And let's give it a texture. And a cool texture that I found was, if you have a look in this folder, I went online and I found tiger skin pattern. So remember, I showed you in Photoshop actually how to get rid of this just by using the levels tab, and then after using levels, I got it down to a nice and clean black and white. So you're going to be amazed to see how I can literally, and this is just from a raster image. So what it does, it takes this image, it wraps it around the 3D model, and it creates it kind of like as a heat sink. And instantly, you're going to have a pattern that will cover your 3D model. Now, this can be very useful, for instance, if I have to print something that must look similar to a piece of wood, and then automatically the wood grain can be in there, or whatever the purpose might be. Like I said, I did find a coral surface for that sculpture, so that one is still coming up, and I'm sure we're going to use this process. So now, let's go here to texture, and I'm going to put on a custom texture, cylindrical. Yes, I'm happy. Yeah, that's fine. And let's select the tiger stripes. And automatically, it puts the tiger stripes on my model. How cool is that? Okay, so it wraps the pattern around the object. And as you can see here, it joins it equally. So that's pretty cool. You can go play with the settings and change that. And all I need to do now, okay, I'm gonna have to just make it a bit smaller again. Now I just need to slice it. Main template, yes. I'll keep the settings as I did, and I slice it. Yes. Do you want to turn off thin wall detection? Yes. It's doing its job. Okay, so the cool thing here is it's telling me, so if I'm going to print this, it's going to take about 17 hours to print, and it's going to take nearly 200 grams of filament of material, and the estimated price is about $6. So that's very cool information for me to have, especially if I'm printing for clients and I need to put on a markup and utilize it as a business tool. So we're going to go to preview. And as you can see here, that pattern is now embossed in my model. So it's going to have that texture. And yeah, I think this is a very, very, very cool feature. And I thought it would be nice to share this. We can also have a look at the print process. So let me just give you a better top view. So remember I said about the infill. So this has got a 20% goroidal infill, as is a more of an organic infill. But apparently this is one of the faster ones just because of its structure. But as you can see, it's also super supportive, strong. It's a very, very strong infill, a bit more of an organic shape than the cubes. Okay, so there we can see how it will print. And yeah, I think a very cool feature. I just wanted to share that with you guys. Let's get out of here. It's fine. All right. I'm going to get back into Fusion. We can get back to the swallow. In the meantime, let me play that short video of the 3D printing, just to give you a little bit of an introspection on the 3D printing game. Before I do that, are there any further questions or anything that I said that's of interest or that you want to know more about? If there are any questions, you're welcome to ask me. Okay. Okay, let me start this.
What is additive manufacturing? Additive manufacturing, also known as 3D printing, is a process that creates a physical object from a digital design. An engineer designs the object using computer-aided design, or CAD software. The 3D design file is then sliced into thin layers and uploaded to an additive manufacturing machine. The manufacturing process begins once an extremely thin layer of metal powder is spread across the platform. A heat source, such as laser or electron beam, then melts the first layer of the 3D design. The platform is lowered, and another layer of metal powder is spread across the platform. The layering and melting process is then repeated until the part is complete. The metallic powder is removed, and a physical object is revealed. Additive manufacturing allows you to produce parts that are lighter, stronger, and more durable than traditionally made parts. Build times are faster. Engineers can add precise features and complex geometries without increasing cost. In fact, additive manufacturing is revolutionizing the way we work.
All right, so a little bit of a sneak preview there. It's a bit more of industrial 3D printing, so that's high-end laser sintering and powder printing. Very, very expensive machinery, like in the millions. I don't know if you know, the CSIR has got one of the biggest printers in the world. They do print titanium there. But yeah, so high-end. But also just gives you an idea of how the process actually works. I'm sure most of you have seen the FDM 3D printers and how they work. Okay, let's try Fusion again. Let's see, where's that file of mine? Okay, that seems to be performing a bit better. Nothing like a good reboot. Insert a SVG. Select the bottom plane. Okay, 10 will suffice. Okay, so again, using the SVG, the drawing, remember it always starts with the drawing. We disable the body, and from the drawing, you then start manipulating. Excuse me. Excuse me. Let's disable this. That. Okay, I'm going to enable my body again. And then we're going to extrude again, but start from the object plane. Start here, and let's just do a -3. Okay, now there is a problem there because now it's selecting. No, it's not what I want. I'm going to cancel that. So if I disable this body, where is this one going astray? Okay. Let's try that again. So all I'm trying to do is to get the outline. I don't want the inner detail, just so that we can put a relief on there. Okay, that looks good. Okay. Let me just get this one as well if I can. And I'll enable the body again, and I'll do a reverse extrude. I'll go from the object. Do like a -2. Disable the sketch. Could have maybe heard the noon gun go off there in the distance. And maybe just inspect the different color. Yeah, and there you go. So there, from a freehand sketch, I've got a nice and detailed swallow model. Now I can still go and change a lot of things on here. I can go and fill it and round it and shape it further. But I think let's keep it at this. This could actually make a nice little brooch or ornament for someone. I'm not sure. But the main idea was to maybe just illustrate a fairly complex freehand sketch that can still be brought. If I can change the view a little bit here. If I change it to shaded with visible edges, you can see a bit better what's going on here. So you can see all the details. And all those points that you saw. So it's all these little registrations here that were were showing up there, all those various points. Okay, so yeah, just to show you that as well. I'm going to close this one. Can I ask that we do like a quick 10-minute breakaway? I just want to have like a glass of water and just a short break. And then we're going to come back into Fusion, and I'm going to show you the design process within the CAD software. So this is where it becomes a little bit more high-end, a bit more technical, and you need to understand your softwares, but it's also important to showcase that. Is everybody good with that?
Hi, Alex.
Hi.
Yeah, I think we can go for like a 10-minute break, and you can just leave your screen, and then after 10 minutes, everyone can come back. You don't have to leave the Zoom meeting. Yeah.
Okay. Any recommendations? Any feedbacks? Everything going well so far?
Yes, everything is going well so far. Shansha and Nyambura on Softcard are enjoying the workshop as well.
Okay.
So yeah, no, so far everything is going well.
Okay, excellent. Okay, great. So yeah, so let's 13 minutes past 12. Let's continue. Okay, is everybody back? We can continue. So I think let's dive into Fusion and let's have a look at the design abilities or capabilities of this software. So there are actually a number of ways that one can design within Fusion. As you can see, it's got the design tab here, and this is the normal way of designing solids. I'll give you a quick demo. If I go create a sketch, I select my top plane. I select a center diameter circle. I make it 70 mils in diameter. There's my first sketch, finished sketch. And then all that's left to do from here is extrude. And I can extrude it by 100. And there is my first solid object. And that is a body. And then what I could do is I could modify this. I could chamfer it, for instance. If I chamfered that by 20 mils, it would look like that. I could fillet it. If I filleted the other side by 20 mils, it would look like that. And this is basically the process. This is how you, well, I mean, there I've nearly designed some kind of a container. So it's actually quite easy, but you just need to understand where your tools are, what they do, and the modifiers, where they are and what they do. Extremely powerful software. There's so much that you can do in here. There are literally hundreds of tutorials on YouTube. Personally, I've taught myself on YouTube. So everybody that wants to get into CAD design, the resources is there for you to actually do it on your own steam. All right, so I just wanted to give that demo. So I can roll back here on my history line. I can go all the way to the beginning, and I'm going to delete whatever I did. So let's have a look at, if I've got an image and I want to, let's use this the same process that we just did just now. So I illustrated in Illustrator and in Photoshop and brought it into Fusion 360. But what if we want to do it all within Fusion 360? Let me show you what that looks like. So let's start with inserting an image. And that's insert canvas. And let's use something from the Fak'ugesi poster. There's a little robot guy in there. Let's see if we can draw him. Okay, so now it's asking for a face. Like, which face do I want to put it on? And I reckon the front face.
Afternoon, everyone. I'm just going to quickly try and get a hold of Alex. So just give us a few seconds. I think he's just lost connection. So I'm just going to give him a call and try and get him back online.
Sorry, guys. I just had a problem there with my internet connection, but it seems like I'm back in.
No problem. Yeah, we noticed, but you can proceed.
Okay, cool. All right. Sorry about that. Okay, so I took a part of the Fak'ugesi poster and I just cropped it and inserted it into Fusion. So this is going to be my canvas. I can use this as my tracing element. Let me move it up a little bit, put him there in the middle as such. Okay, as you can see, sort of already a little bit opaque. So that is just so that you can trace properly. You can actually change the settings. So you can go and change the size to the exact size that you wanted. If you know you want to build him about 500 mils, then you can measure from top to bottom. You can orientate the size, the opacity, and all those features. Okay, so let's do the basics. So what I've been doing up until now is just starting with the 2D sketch. So what I can do is, and this is going to illustrate how everything basically can be drawn with those three elements that I mentioned earlier, the cube, the cylinder, and the sphere. So I'm going to go create sketch. We're going to create it on this plane. I'll start with my center diameter circle. So I started with the face, now I'm doing the shoulder joints, elbow joints. So you may imagine that we're using the sphere over here. Okay, can I fit another sphere in somewhere? Good, maybe for the body. Yeah, why not? Let's do, that's going to be a bit more of an ellipse. Okay, so the ellipse measuring from there to there to there, similar to a sphere. And next shape, let's do the cube. So I can do the 2-point rectangle. That's similar to a cube. There I'll actually use, yeah, I can use them here. Use them there. Okay, let's go back to the ellipse again. Well, let me show you. So if I go to the spline tool, so just making lines, but the shapes are similar. So basically you'll be using cylindrical shapes there. But if I start from here, and I do the same here. And we've got something happening here. He's got a bit of a mohawk. Actually, let's get out of there. Where else? His arms. There's one there. So making use of basic shapes. You remember I did something similar then in Illustrator. Okay. Oh, and he needs, let's give him a base. So we'll do one more. Let's do something like that. Oh, no, that's not what I want. Can do that. Okay, let's give him his eyes. Oh. And he's got quite a big grin. And let's give him an ear. And here's also something happening. Now he's got little goeters here. He's got little antennas happening there, and they also kind of connect via T-spline. Oh, that's not what I want. Go in there. And that's done. And one more here. What happened to this guy? And his antenna. Yeah, that seems good enough. Have we got all the elements? Seems good enough. Okay, so by tracing a canvas, there's our little guy. Oh, he doesn't have fingers. He does not have fingers. We'll just use a couple of quick ellipses for that. Yeah, here we can use ellipse as well. Here's another ellipse. Let's try again. And 2 more ellipses. And I think that should do it. Yeah, there he is. Okay, we say finish sketch. Oh, no, I'm lying. At least I can. So the nice thing, if you know how your software operates, you can always go back and you'll see here on the timeline. So the first step I did was import a canvas. Second step was to do the sketch. So I go back to sketch and I go edit sketch. It puts me back in the sketch environment. And by using the trim tool, I can clean up a bit now, all the stuff that I don't want. And this software is clever enough to know what to delete. So wherever it connects, I can now go and clean up. Which one is it going to be here? It's going to be like that. Okay, like that. Here we go. And this again is a good example of how to draw with basic shapes. And it goes to prove that anybody can draw, really. If you know these shortcuts. And to be quite honest, the most difficult thing to draw really is a straight line or a perfect circle. And this software allows you to do just that. Yeah, looks all right. So, in the end of the day, Fusion actually has its own Illustrator built into it. So if there are any of you who know Illustrator, you can just as well do it in Fusion 360. And it also gives you the ability to export it as a DXF if you had to use it in other applications. So not only is it a 3D modeling software, it can also be used as a vector illustrator. Doesn't have all the fancy buttons that Illustrator has for final presentations when it comes to drawings like this. But for technical drawings, you will be sorted. Okay, we're nearly there. Yeah, there he is. Cool. So grabbing a canvas, tracing it out with shapes, i.e. circles, cylinders, cubes, trimming it, and there you've got your little character. You can maybe delete this guy here as well. Yeah, let's do that. All right. And from here, okay, so let's finish sketch. Actually, let's see if we can select, can we select these points a bit? So can we? Okay, no, I'm not going to worry about that. All right, what do we want to do? Okay, let's select everything. It's fine. Even select that. Ah, no. Let's do a window selection. Yeah, there we go. Okay. Let's go up with 20 moles. Up with 50 moles. Yeah, better. Make it 70. Okay. There's our guy. Let's switch on the sketch again. And let's switch off the bodies. So what we're going to do now is we're going to do indents here. Let's do indent there. Okay. Bodies on. We do it from the object. We'll go -5. Right. Let's see if we can do something here. Okay, I can't do that on its own. Disable the bodies here. So if I go I have to edit the sketch again. Do that, and I can just do an offset, and I do it of about 5 mils. That should be fine. And let's do the same on this side. Do a 5 mil offset there. And then I just link these guys. That should be all right. That should be fine. Just want to close these gaps over here and see if I can do an extrusion for these guys. Finish sketch. Should do the trick. I have to activate the bodies again. Q. Let's do it 10 moles. New body. That's good. And the same here. And 10 moles. Make it a new body. That's right. Let's have a look at him now. Turn the sketch off. Yeah, there's our little guy. Not too bad. Okay, so still, but this is more of a 2D to 3D design. And this was done in the solid space. Okay, so I would call this standard grade design. There are, one can go and tweak features. You can give him little eyes, give details. Let's see what happens if we fillet him, for instance. If we did that. We can still get maybe like a better quality out of him. I'm just going to give you an example here on this side. So let's say, did I go there? 100, so maybe 20. No, 20 is too much. Even that's too much. Yeah, that's, why is this not allowing me? Okay. Yeah, so some of the curvature is not going to allow me. I did it at 1 mole and it works. 4, also not. Okay, so anyways, I just wanted to see if we could use a fillet here, but the, some of the curves here are not agreeing with each other. So that's fine. But yeah, so what I would call kind of like standard grade design work. Applicable to many things. But let me show you what I started with the other day. So I started in the sculpting workspace, which is this guy here. Now, this is a whole other way of designing. This is where you use the T-spline, and it is geared for organic designs. Okay. I can actually illustrate it on this very same. So let's, okay, thank you, goodbye. That guy's done now. We're going to go all the way back to before the drawing, just the canvas. So let me activate that canvas again. I'll click my home button. I'll go to the origin. Okay, so I've showed you how to design in the solid workplace. Let's go over to how to sculpt or how to create a form. Okay. Actually, exactly the same principle. But what we're going to do now is we're going to go and create shapes straight in 3D with the right curves. And you're going to see it's a lot more organic, and that's going to bring us closer to what we actually want. So for instance, if I want to create another sphere, which plane are we going to do it? We're going to be on here again. Okay. Okay. let's see, longitude 8 faces, latitude 8 faces. That should be all right. Okay. So that can be his face. But now if you look at his face is not completely round. So there's actually a lot of elements here that we can go change. So if I go to modify, edit form, I can start manipulating this guy a little bit here. I can get closer to his real form. So as you're seeing now, so I'm basically sculpting as if I've got a piece of clay. And herein lies the true power of creating 3D objects. Okay, so now we're getting closer and closer. This guy is like a modern, happier version of Bender. It's got a bit of a chin. Okay. I'm going to leave it at that. So if I look under bodies, then you'll see I've got a mesh body. Now what I'm going to do is I'm going to turn this mesh, because he's not looking to the side. He's kind of like looking, what's the right word for that? Perpendicularly. Something like that. Okay, yeah, there we go. Okay, so there's the head. Now he needs a neck. Okay, so I can use a cylinder for a neck. I'll go create cylinder. And I'm going to do it on this plane. And it's going to go under his head about there. And yeah, let's leave it like that. Oop, that's yeah, that's good. Height 50 more. And that's body 2. Move copy, move it up. Not so much. 145. Yeah. Yeah. Okay. It's got a neck. I think the neck must move in a bit more. You see. Okay, that's fine. Modify, edit form. Make sure that I select the correct edges. Yeah. Okay. And is it Alt? No. Modify, edit form. No. Is it? I don't think so. Okay, no, that's fine. All right, so there's the neck. What do we need? The mohawk. Okay, I'm gonna have to also draw on this plane. I think the mohawk, I can wing it without the canvas. So if I go create sketch, bottom plane, and I'll use my spline tool, and there, there, and there. Yeah, and that's okay. Go select, bring these points in a bit. Yeah. Yeah, I think I can work with that. It's a bit big. It's going to be a bit big. Maybe. Okay, now I think I need a bit more points there. I'm going to roll back a bit. Go top. Spline. So let's put a few more points here. That's better. Yeah, I think that's closer to what I'm imagining. Yeah, I'll give it a bit of a curve. Why not? Finish sketch. Where's my sketches? It's there. Create, extrude. Okay. Yeah, 60 is good enough. 8 faces, but I also need front faces. That's better. And that's body 3. Move and copy. Get the placing right there. Yeah, it's better. Okay, and now, okay, modify, edit form. And now I do the same thing again. I want to get these guys in and down a bit. Start with this guy. I can actually use this whole face here. All of those. Need to bring them in a bit. It's not quite what I want. Yeah, that's a bit better. Get these guys in there. All right, and modify. There we go. So as you can see, Mr. Robot Man is coming on quite nicely. Let's finish here with the neck. And then for the last, we'll just go again, modify full hole of that one, this one. And okay. And voila, there you've got it. So this is how you model in 3D. Well, one of the sculpting ways. There are very powerful other softwares that animators use. So the competitors of Autodesk and Fusion 360 is SolidWorks, and then there's an open source program called Blender. Blender allows you to create assets for gaming and film and for 3D printing. This is typically a sculpted form that can be used for animation. It's not solid yet. One has to solidify it, and then only it will be ready for 3D printing. Then you get very advanced animation softwares called ZBrush, where you sculpt in a lot more of an organic environment. And there is also a 3D program called Tilt Brush that you do in a VR environment, where you can actually, it's as if you're in the space and creating within the space. So yes, yeah, many different softwares, and also quite a number of different techniques and methods to utilize. But yeah, guys, I think that actually brings us to the end of our workshop. I think I've shown you quite a number of different techniques, but what we're looking at here, I would say this is the boss technique, and this is where one needs to get to eventually. Obviously now from here, you know, I'll put in all the extra details. I can build him. Maybe I'll take some time and I'll actually finish him and see if I can print out quite a cool 3D printed version of the robot. But yeah, it's going to take me a bit of time, most likely a day's work, maybe 2 days work to do it really nicely, you know. I hope you guys have enjoyed today's workshop slash lesson. If there are any questions, you're more than welcome to ask me. Now is a good time. TK, are you still there?
Yeah, I am still here. Multitasking, but definitely enjoying the workshop. I think for me, what's been interesting, because I've been contemplating on studying architecture next year, and I have to submit obviously like a portfolio to study. So part of me is now trying to, think about how complex it might be to try and develop something that could be printed in 3D, for my submission. So yeah, so it's very interesting. Obviously, it's quite complex in terms of the software and the applications and the type of computer that one would need to use. But yeah, I've for me personally, I've learned a lot, and yeah, it's really pushed me towards how can we, create more content, using these tools that are, in line with architecture, basically. Because my train of thought within going into architecture was more of, using immersive reality, virtual reality, and augmented reality, basically, to try and build these different infrastructures or plan different stuff. But yeah.
Yes, absolutely. These, especially the Autodesk range, is amazing for architecture. I mean, today's lesson was a bit more for the creative or the illustrator, because that doesn't actually get attention. So, and since Fak'ugesi is an arts festival, I thought I'd do that as a bit of a swing to show people what's possible in a bit more of an illustrative medium. But for architecture, so what I'm doing at the moment is all my builds, all my project builds, which are installations for events. I did an event installation recently. So that is a mini architectural stand, and there was a lot of engineering that went into it. So Fusion allows you to design and build a 2-spec. And I used that, and then I rendered it, and I showed the client exactly what this is going to look like. They approved it. I got the commission. I built the stand by using the design that I had in Fusion. I just sent it to the CNC machine, to the milling machine. The milling machine already had, the plans were there already, molded out, and all I had to do is assemble it. So that is where it becomes very, very powerful. And I've been doing this for a long time. Back in the day, I started using SketchUp back in the day. And then I would design decks for people's houses. And if they approved that, then all I had to do is create a cutting list from that design, send the cutting list to the timber yard, and my wood was ready, and I could go and install the deck. So there's lots of things that one can consider. And when it comes with product development and when it comes to architecture, there's also simulations built into these softwares that can test. It can do a simulation and do a strength test, for instance, of a part or of an area. And tell you even before you get to building, it can tell you, no, your strength ratio here is not good enough.
No, thanks for that feedback. No, that's interesting. That's definitely something that we'll look into further. I don't know if anyone else has any questions. Do feel free to unmute your mic and ask.
Maybe we can. I don't know who's listening in on a pause. Who's using a pause computer? There's somebody there.
Yeah, I think I'll have to just quickly follow up with the guys because I think they had just gone on a break just now. So I need to, yeah, we can maybe take another 5-minute break and then I'll just find out how far the guys are that side.
Check with them and let's see if that jack-o'-lantern print came out. Maybe we can have a look at that, and we can also check in and see what their progress is.
Okay, I'll do that now. Thank you.
Okay. Okay, cool.
Everyone, yeah, I'll be back in 2 minutes.
All right.
Afternoon, everyone. I'm back. So Alex, yeah, the other guys are gonna just briefly update us on their side. I'm adding them to the spotlight. They're not yet ready, but yeah, they have started printing the work that you have sent them. Yeah, I think Paul, you can just give like a brief feedback.
What?
Sorry.
Good day, again.
How's it, Mpo?
Good. How did it go there? I heard that guys you are done there.
Yes, it went very well. We actually covered quite a lot of topics. Like I said, I approached it more from an illustrative aspect. So, you know, we did freehand drawings, and then from freehand into Photoshop, downloading raster images from Photoshop, converting into Illustrator, moving it into Fusion, and then extruding and creating 3D objects. That was one of those first ones, like the little jack-o'-lantern. That was literally just a little image that we grabbed from the internet. It had a watermark on it, showed them how to remove the watermark and actually how to convert it and create a 3D object out of it. And then, yes, we kind of climbed the ladder until we ended with how to actually sculpt in CAD software. So from the basics all the way to the top, the demos there. And yeah, it's for me, it's good from my side. Didn't hear much from the other people, but silence is normally a good thing in these cases, I hope. TK said, yeah, TK said he's quite interested from an architectural approach. So yeah, everything went well. How did things go there with you guys?
Okay, that is fantastic to hear from you. Yeah, here things are going very well. Even though like pretty challenging when we were first maybe like teaching first tools, how to use tools, different tools to design. But yeah, I mean we have managed. Like now we are almost done. So like some of the other guys they just need to extrude. But yeah, we are almost done. So maybe when we connect again at half past one, we can show you, can turn the screen, or maybe you can use a phone to take some, to show you like the videos, what the guys like done so far. And then I mean like even like some of the participants, they were very like they're actually enjoying it. So they want to add some of the stuff on top of the design. So yeah, I mean it's going well.
Well, you might, if there's anything to show, you can show it now, Paul. I mean, it's only another 10 minutes really, so it's fine if you want to show me something now. Show me the progress on it. Is that jack-o'-lantern still printing there?
Yeah, that one is the printing. So
just show us the progress on that, because we all saw the digital image. I just want to see how far that got.
So, but how can we? Because now this camera,
I see.
You can't take it.
Take a phone. Take your phone. Take a photo of it, and then hold your phone in front of the camera at the screen.
So take a picture and then give your phone with the picture.
Oh.
I think we're having an issue because the sound is now pinging on our head.
Oh. Oh, okay. So we'll turn down the volume on the screen.
Okay, thank you.
Cool.
So why don't you use the camera?
It's connected.
You want to put it TV? Did they not leave it? It's fine. I found the. Hey, Alex.
Yeah.
Okay, hold on. We're just adjusting the volume.
Okay.
Because we're disturbing another venue, another event.
Oh dear.
Okay, let's see. Okay, bring it to the.
Okay, it's nearly there.
Yeah.
Nearly there. Okay, cool. Well, you can, yeah. Maybe you guys can throw some numbers into a hat. Maybe somebody can win it or something.
Yeah, I was gonna suggest maybe we could try and organize a phone for like just the next maybe 10 to 15 minutes that will just focus on what's being printed there. So one of the phones that are in the account.
Oh,
unless if you
yeah,
want to be saying.
Oh no, it's all good. It's all good. No, Paul, I'm very glad. I'm glad that you guys had a good workshop. I hope everybody learned something new today. That's normally the case. These technologies and softwares are always quite, advanced and unknown to most. So, and maybe to end off the workshop, it takes a long time to master CAD. It takes devotion. It's like, I've been doing it for years now, and there's still so much to learn. There's people out there, we refer to them as CAD ninjas, and some of the work that they do is just really, really incredible. So one aspires, and yeah, I mean, I learn daily. A lot of some of the techniques I showed you in the workshop is what I learned recently. Like I explained, the heat mapping or the surface textures. And yes, and also often how you learn is when you're confronted with a fabrication problem or a challenge, and you have to figure out a new way of doing it. That's how I often learn, is when I'm challenged to find new ways. But yeah, I mean, from my side, then I hope you guys enjoy the rest of the session there with them, Paul. If there's any other questions or anything, you're welcome to ask. Otherwise, I'm signing out.
You guys are great.
Okay. Cool, guys. Cheers. Adios. Bye-bye.